No.
All right. Hello, everybody. Welcome to today's Energy Showcase from Deep Tech Showcase. So for today's agenda, we'll be having this opening remarks and meeting the panel. Then we're going to have two sessions where companies will pitch their technologies, each one about an hour and a half. Just to talk a little bit about who we are running Deep Tech Showcase. The vision of Deep Tech Showcase is to bring the deep tech to market by leveraging the power of community. And this community consists of startups, tech scouts, and investors. So the startups, of course, are interested in getting connected to the tech scouts, among government and corporations. Tech scouts looking for innovative solutions to solve some challenges they might have, or interesting partnership opportunities, potential acquisitions in the future, strategic investments, so on and so forth. And investors are looking for deal flow. So we bring all this together where each group are seeking to collaborate with each other for various reasons. So anchoring our ecosystem are monthly showcase events, such as this Energy Showcase. Each month it's a different theme. So as I mentioned, this is the energy event. Last month we had an advanced materials showcase. The previous month we had aerospace and defense. Next month, autonomous systems. But we also have space, microelectronics, semiconductors, industry 4.0, you name it. So we have a bunch of industry themed events throughout the year. And at these events, deep tech startups pitch to a panel and audience of tech scouts from government and major corporations and to investors. Aside from our events, in between our events, or on top of our events, we offer guided introductions. So we have stakeholders saying that they're seeking specific types of technology. Let's say energy technology as a totally random example. And if we're working with companies who fit their thesis or an industry that they're interested in, we send them some company profiles for them to review with some basic information about the companies. And if there's interest on the stakeholder to connect with the company, we make a warm introduction. So that stakeholder already knows some basics about the technology and express interest in meeting up with a company. So it's a pretty good starting point, much better than any cold outreach. Some of our upcoming events are autonomous systems next month, and then in October we'll be having our space industry showcase. So we'll be happy to have everybody here join that if you'd be interested and available. And now a word from our sponsor, Eagle Point Funding, and we have Benjamin Sampson here to tell you a bit more about what Eagle Point can offer.
Thanks, Brian. I'm not going to take too much of everyone's time. Just want to tell you a little bit about who we are here at Eagle Point. We're a grant consulting and a grant writing firm. The idea is we work with you or your clients to help find and win non-dilutive R&D funding for the government. So SBIRs, STTRs, broad agency announcements, and OTAs, handling everything from the sourcing of the grants that are out there to actually doing the vast majority of the workload, technical documents, the budgeting, business proposals, formatting, editing, laying it out, submitting to the agencies, communication with the agencies, whatever we can take off a client's plate, we do so that they can focus on their R&D, focus on building their brand, and not have to worry about the grants. And so we work with our clients for about 18 months, apply to somewhere between 15 to 20 grants that time, capitalizing on our 25 years of experience in this space to really know the agencies, know the program officers, knows our clients, and know what is going to help them win and put them in the best position to walk away with funding. So if you'd love to talk, if you'd love to better understand what we do, please don't hesitate to scan the QR code, book some time with me, reach out to Brian. Brian will happy to give you my contact information. We've got some good availability post Labor Day, and we can talk and we can see how Eagle Point can help you find and win this government money. So, Brian, back to you.
Recording in progress.
All right, thank you so much, Benjamin. Definitely. If you want to leave your contact info in the chat, actually, I think that'd be great. Chat set for everybody rather than host panelists, so everybody can reach out to you. Highly recommend reaching out to Benjamin. totally unbiased opinion. Anyway, so here are the companies who should be pitching for this session. And we're going to go through our panelists shortly. What we're going to do with our panelists are we're going to call on you, and you will just describe yourself or introduce yourself briefly, describe what tech you're interested in, so on and so forth. So with that, I will go through the panelists here. So the first one I see is Chris Gruby.
Knew that was going to happen. Hi, Brian. First time on this group. Thank you very much for having me. My name is Chris Gruby. I run a vertical within New World Angels for industrial and manufacturing, which includes energy and clean technology. New World Angels is about 120 members, largely based in Florida. We've been around for about 30 years, and we've been seeing more and more in harder assets, defense tech, and so on. So excited to see the deep tech go on personally. On my background, I'm a retired project finance lawyer who with a lot of experience in newer technologies, renewable energy, and climate tech. My last job was I spent 7 years as a partner with Wilson Sonsini, which is a big technology-based law firm, helping companies that were past the venture capital stage get later stage funding and eventually either government or project finance to get their first projects done. So love the space. Very excited to see some new companies in it.
Awesome. Thank you so much for joining us. Happy to have you with us. Next up, we have Lawrence Hayward. And you're on mute.
Try that again. Hello, everyone. Larry Hayward, founding partner of Adams VC. We're a venture capital fund focused on early stage hard tech innovations, mainly in health, sustainability, and automation. Glad to be here.
Glad to have you with us. Up next, we have Mark Rake.
Good afternoon. I'm Mark Vreka. I'm with the Chemical Angel Network. Chemical Angels, it's an angel network like any other, a group of accredited investors. What sets us apart is our chemistry focus. We invest in the 3 M's: materials, measurement, manufacturing.
Awesome. Thank you so much for joining us. Up next, we have Robert Evan.
I'm with M Ventures, which is the corporate venture capital arm of Merck of Germany. One of our main businesses is electronics, so we invest in semiconductors, and we look for some sustainability opportunities within semiconductor, things like chip cooling or data center energy improvements, things like that. And I've been with the fund 5 years, and my background is mechanical engineering MBA. Thank you.
Great. Thank you so much for joining us at this event. Up next, we have Gerald Wang.
Yeah, good afternoon, everyone. So my name is Gerald Wang. So I'm from GC Ventures. We are corporate venture or PTT GC. So that is a Thailand-based petrochemical company, $20 billion US dollars revenue every year. So our lens on energy is pretty broad. In terms of energy transition, we're looking at some green energy like green hydrogen, green ammonia. And about energy efficiency, we're looking at the material innovations such as composite 3D printing for lightweighting, and etc. So look forward to joining this session and understand more about the technologies. Thank you.
Great, thanks. Really happy to have you with us. Up next, we have Martin Adu-Boaene.
Hi, everyone. My name is Martin. I'm currently on the Azure Hardware Finance team at Microsoft. And prior to that, I was with DCVC, which is a deep tech fund based out of Palo Alto. Happy to be here as well.
Great, really happy to have you with us. Up next, we have Sam Kim.
Hi, everyone. My name is Sam Kim. I am from Austin, Texas, where I run a venture capital fund called Banyan Ventures. We focus our investments in hard sciences, primarily advanced materials. We love to work with corporate VCs. In fact, every single one of our deals has a corporate VC on the cap table. We've done deals with Merck. Robert, I see that you're with Merck. We work with Owen Losman on a print electronics deal. We work with Fujifilm, Applied Materials.
Great.
So happy to see everyone here on the call and glad to be part of this. Thank you.
Great. Thank you so much for joining us. Up next, we have Samira Curtis.
Thank you for having me. Yes, I'm a founder of Raw Lab Ventures, and I'm a venture partner with the VU Venture Partners. And focus is with the VU, we focus on, it's pretty much agnostic. So we invest in all kind of industries. And on Raw Lab, I'm focusing on deep tech and Web3 and AI. And that has been also my experience. So I also help founders not only with funding, but also with the acceleration of their business. So, and mentoring and coaching them.
Great. Really happy to have you with us. Up next, we have Tito Colmenares.
Hi, everyone. I'm Tito. I'm engineer and angel investor based out of the San Francisco Bay Area. On my full time, I'm developing next generation battery technologies for Mitra Chem, a startup here. And on my spare time, I work with other startups and invest as an angel investor and consult and help them grow in mostly the deep tech energy space.
Awesome. Happy to have you with us. Up next, we have Ariel Heyer.
Hi, everybody. Happy to be here. My firm is Clean Energy Ventures. I'm an analyst here, scientific background, PhD in chemistry, as well as a master's in public policy. And CEV is a climate tech firm. We focus primarily on technologies that have the potential to reduce greenhouse gas emissions by 2.5 gigatons by 2050. The actual technology is pretty much irrelevant as long as you can hit that benchmark. So interested in everything. Happy to be here.
Really happy to have you here with us as well. And we also have Paul Garcia.
Hi, Brian. Good to see you again. Apologize, no camera. The new compliance Air Force computers have had their cameras taken out. So I am still actually here. I am with the Air Force Office of Energy Assurance. Air Force divides energy into installation energy and operational energy. And I work on the installation side, which for those who aren't familiar, is pretty much anything that is utility connected. So operational energy deals with tactical, forward, mobile, any type of aircraft, that type of energy. And installation is power, gas, water, and things that are normally utility connected. This is my favorite showcase. I like this one the best, of course, because energy. But looking forward to seeing who's here. I see two familiar faces and looking forward to the new ones.
Awesome. Same here, and I'm really happy to have you with us. I believe that's it for the panelists. If you escape my field of vision, please let me know if you're a panelist, because I'd hate to accidentally omit you, and then we could have you introduced as the event goes on. But for now, we'll dive into our presentations, and our first presentation is Glimpse. We have Eric here to present. So Eric, we're running about 5 minutes early, but you'd be ready to present. We'd love to have you share your screen and see your presentation.
Sounds great. Does that mean that I have 10 minutes instead of 5? It's a joke.
We can be a bit lenient, but
it's fine. It's fine. Yeah. I'm joking. Hi, everyone. My name is Eric. I started Glimpse with my two co-founders about 1.5 years ago, and I'm originally from Tesla. I'll walk you through the team at some point in the presentation. We're just about to fundraise, actually, so this is good timing for us. And I'll tell you a little more about how much we're raising and why. A high level, like I said, it's been 1.5 years. We're building a quality management solution for the battery industry. And we launched our product in March and have many customers that are returning, such as companies like SpaceX, Rivian, NASA, Lucid, and a couple others. And we just announced today our first deployment at Lucid, at the Lucid facility in California. So I'm excited to share more about what we do here at Glimpse. Like I said, we're 3 co-founders. 2 of us were at Tesla before starting Glimpse. We spent 4 years there, and we're working on. We initially, we're hired to work on next-gen batteries, but we ended up being sort of hired and asked to handle battery field failures, which were happening throughout the industry, not a Tesla-specific issue. And those were caused by defects that were uncut in battery cells and making their way into cars. So real quick, how does that work? You got battery cells that are built into battery packs. So in a battery pack, you typically have a few hundred to a few thousand of those cells. And the kicker here, if there's one of those cells fails, then the entire pack is most likely going to have to be replaced. So it's an incredibly costly event for OEMs. And oftentimes they have to fight very hard to get a chargeback from their cell supplier. But in any case, they sort of bear the reputational risk and the brand damage from those failures. This is a very widespread issue. Battery-powered product recalls are in the $8 billion plus range today worldwide. And then a number that I think is crazy, but we've confirmed it from various sources, is 2.5% of all EVs on the road today are going to fail during their warranty life because of its cell defect. And then very unfortunate statistics on this page that people are dying from those failures. So it's not just a dollar value, but it's also a societal cost. And the reason is, companies are pressured to introduce new designs, reduce cost, and keep their factory running at full rate, and that puts a lot of pressure on battery quality. So this is a big market. Because I don't have a lot of time, I will skip this slide, but at a high level, the battery market is large, and within this market, you have the battery cell quality market, which is about $11 billion today, and this will grow with the size of the industry. Why you have so many failures and escapes? It's essentially because you have those cell quality teams that are performing a lot of various labor-intensive workflows and working across different data sources that live in Excel, PowerPoints, Words, etc. And they're essentially incapable to perform their work at scale. But because they operate in factories, they have to operate at scale, right? Like a factory produces hundreds of thousands to a couple million cells per day. And those quality teams are on the hook to determine whether a given suspected issue or a given batch is sellable or not and can go downstream. And so a big reason why you have so many escapes is because quality teams are not able to perform their work at the scale that's needed to evaluate quality, cell quality. So what we're doing is sort of pioneering this QMS, quality management solution, and think of it as the new operating system for cell quality teams. So if some of you have heard about MES, manufacturing execution systems, you know that MESs are sort of a software layer that live above the factory and that drives factory efficiency. So it's kind of the operating system for production teams. And what we do at Glimpse is we build the operating system for quality teams. And the good news about this is that there's only one production team for battery cells, but there are 2 quality teams. There's a quality team for the producer and the quality teams that work for the buyer. So we can sell our software twice. We're using X-ray computed tomography for this, and it's a great wedge to build this piece of software. We're not going to stop there, but it's a great way to penetrate the market. And the reason is it's a ubiquitous technology. Everybody has a scanner, or the large players have a couple hundred of those. Each scan is a lot of information if you know how to extract them. And the current workflow around CT scanning is incredibly painful. It's slow, it's cumbersome, it's expensive, and data is so huge that it's practically impossible to share it across your organization. So what we're doing is we're scaling the entire CT scanning stack to go from 1 hour to 2 minutes. So today we're at 2 minutes. Next year we'll be at 10 seconds per scan. And in 2027, we'll be at 1 second per scan. These are not fuzzy targets. This is proven that we can get there. We've proven it. So we're very excited about this. And as we scale CT scanning, we're sort of expanding the size of a market. I'm not going to spend too much time because I don't have a lot of time. But real quick, we're building the system of record for battery quality. And today, what's supported on our portal is those scans of batteries. So you're looking inside the batteries, you're extracting features from those batteries, and then you're plotting those features in dashboards, and you turn any scanner into a quality management solution for your customers. But we're going to add more and more data sources on this portal. And you can think of our portal as like a digital piece of real estate that we're inserting in at our customers. And then we can add more and more of their workflows together. And doing so, we enable them to work at scale. We have two models. One is scan on demand. So you send us the batteries, we'll scan them for you, we'll send them back. The other is on-premise scanning, which is more of like a six-figure, core SaaS and six-figure per scanner. On the scan on demand, we've had a very nice growth since we launched our product in March. By the way, we launched our product a year after we created the company. So it was a pretty quick go-to-market. And then we've seen a lot of growth since then. Some logos that you might recognize from our customers that are recurring, returning every month or every other month. And I'll just skip this slide. And then on-premise scanning, which is this recurring sort of SaaS model, subscription-based SaaS model. We just deployed at Lucid Motors. We actually made some announcement on LinkedIn today. Second deployment that we're working on is Panasonic. And then we have a very nice commercial pipelines that we're going to hone in the next 6 to 18 months. I'll skip this slide as well. We're raising between $8 and $10 million. So I'm just about to start fundraising, actually. Nice coincidence. And the goal for us is to sort of accelerate our sales cycle, strengthen our value prop, and improve the scalability of products so that we can sell more and faster to our customers. Yeah. How did I do? Maybe I went too fast, Brian.
Well, you were faster than 10 minutes, but a little bit more than 5, but nothing crazy.
All right,
especially
cool.
since we're a bit early. So, but good job. So now we're opening the floor to questions. So if anybody has a question, just go into Zoom and raise your hand, where you click on more, and there's like a React button on there, and you can raise your hand. Or if you can't find it, you could just jump in. But if anybody on the panel has a question, just feel free to.
I can't find the button for a moment, but I wanted to ask, when you go to market, who's actually putting out the money to buy your equipment, and are they the same ones who are motivated and getting the benefits, or it's the end user down the road? So like, how is your supply chain there?
Yeah, so we're not a hardware company. We don't make the scanners. There is a mature market, and you have many players that produce those equipment, and they have a very low level of differentiation between the different brands and model. So people are already buying scanners for battery manufacturing. This is sort of an essential tool in their toolbox. So we're just leveraging this mature market to sell our piece of software on top of it. Does that answer your question, Robert?
Yes, but so the customer, so the manufacturer of the battery is buying the software, and then he's gonna have less defective goods. Okay.
Yeah, so the ROI, if you will, is they're already using those pieces of hardware, and they're getting terrible ROI from them because each step is incredibly labor intensive, and they have to throw a lot of humans at it. So this is one way of calculating the ROI, is how much time we can save them and how much more throughput we can get out of those scanners. The other way to calculate ROI is how much defect you can avoid downstream, right? And so each defect is going to cause a failure. And so how many of those defects can you avoid? And so that's money saved down the line. So there's sort of two ways to calculate the ROI.
Mm-hmm. Okay.
Yeah.
Thank you.
Hey, Eric, quick question on intellectual property. Is there any kind of new technology that you're leveraging, maybe AI to scan the images, et cetera? Or is it kind of speed to market, get as many customers as possible, as quickly as possible kind of play?
Very much the former. We are, there's quite a bit of technology that we've embedded in our software. I talked about the scan on demand model where we receive sales from our customers. This is actually both to use as a lead generation to sell, our six-figure SaaS offering, but it's also a way to build the largest database of cell design and defects, and we're using those to train our algorithm for defect detection and other things to accelerate scan times. So we're working on a variety of techniques. Some are AI-based, some are Gen AI-based, mentioning this because I know people are excited about this. Some are more boring AI-based, if you will, standard sort of deep learning models. And some of them are non-AI, but there's quite a bit of image processing that we do to accelerate scan time, and quite a bit of computer vision that we do to extract features from those scans.
Okay, and what is the business model when you do an on-premises scanning? Is it per scan kind of?
Correct.
Or is it a yearly subscription, or can you talk more about that?
Yeah, annual subscription per scanner.
Okay.
Per scanner, not per scan, right? So per piece of equipment on which we deploy.
And are your customers scanning, like what percentage of the batteries they manufacture are they scanning?
Yeah, it's a great question. It really depends on the use case. So if you're an OEM that sources, batteries at high scale, currently you're doing pretty much no incoming quality control. And so these guys want to perform some level of quality control, and they have different targets. So one customer is going to tell us, well, actually, I want to scan a cell every 30 seconds. So I want to scan, a few hundred cells to 1,000 cells per day. And I want to focus on these 5 defects that might occur. Other customer might say, I want to scan a cell every 5 minutes because I want to get better image quality and extract more features from those cells. And that's just, an OEM that receives cells. You have also producers that produce cells and they want to check for a specific defect. So it really depends. We have customers that are very happy with 10-minute scans. We have customers that are very unhappy with 1-minute scans. They want to go to seconds. And that's why we're also working on accelerating our scan time. So I'm not giving you a straight answer because there's a wide variety of use cases, which essentially means there's a wide variety of scan throughput that are required by our customers.
I see, but you don't care because they're just paying you based on the number of scans.
I don't care, exactly. It's a trade-off between image quality and throughputs, and as long as they understand this trade-off and figure out what they want, I don't care. I still might sell my solution.
Okay, and last quick question: who are the competitors in this space?
No one has actually built this product, and there's a company that's called Lumifield that essentially built a new type of scanner. So they're actually a hardware and a software company, but they're sort of trying to democratize CT scanner and make it as cheap as possible. And they're solving the equation of, I want to minimize my CapEx or dollar per CapEx. What we're solving here is a very different equation. So that's why we're not competing with them. We're minimizing dollar per scan, which is a very different equation, right? Because if I can amortize a more expensive CapEx over many more scans, then I've reduced my dollar per scan. And so Lumifield is a very cool startup, but we're actually not operating in the same market and trying to solve for the same equation. Beyond that, the scanner vendors themselves are trying to complement their solution with some software, but they're sort of stuck in the 90s for that.
Thank you.
All right, real quick, Tito, want to ask a question?
Yeah, Eric, good to see the progress. I think it's not the first time we interact, maybe in this space or some other space, but I mean, I've heard of Glimpse a little bit. Yeah, just wanted to ask how, what data do you get on or what data you're trying to get from different chemistries, or how does that matter, and how you're differentiating that for your customers as a value add on the battery chemistry, and how are you differentiating in terms of the R&D market that you're targeting versus a production customer?
So I think 2 questions there. So the first on chemistry, yes. We're chemistry agnostic. As long as we have contrast between electrodes, then we can create value for our customers. And in general, you do have contrast within your electrodes. We don't make adjustments to our pipeline for different chemistries. We do make adjustments to our image processing pipelines for different form factors. So if you're talking about cylindrical versus pouch versus prismatic, this is a different way of processing the data and displaying the data as well, right? So that was your first question. And I think I already forgot your second question.
Yeah, my second question was, how are you differentiating your customers, and what market are you targeting the most within R&D and a production customer?
Yeah, So I mean, if you want to think about a market, you would look at this slide, right? So there's the cell producers and then the cell buyers. Cell producers, they have typically inline and end of line quality control steps, and the buyers have incoming quality control and then fill failure management. We have some customers that want to do R&D with the solution, but typically our solution is built for scale. And where you're doing R&D, you're now working at scale. So we have had interest from customers that are doing R&D, but I doubt this will convert to a large contract value, right? Where we see the most value and where we're going after is people that need to operate at scale and test a lot of battery per day or per week or per month. And so these are the sort of main use cases that we're targeting today. So we just deployed at Lucid, like I said, which is a sort of IQC use case, incoming quality control, and then second deployment will be a cell manufacturer.
Yep, makes sense.
Cool.
All right, thank you so much, Eric. And I'm just so everyone doesn't get confused, I'm jumping in for Brian here, and we really appreciate the pitch, Eric. Next up, we have Spinkly, and yeah, Spinchy. Whenever you guys are ready, feel free to start sharing your screen. Oh, and Brian says that I should introduce myself slightly. Sorry about that, everyone. I'm the managing director of Deep Tech Showcase. Happy to be here today. Happy to see some really great presentations. I was running a little bit late, but happy to finally be on now. Lamar, take your time getting the slides up. It's all good.
Sorry about that. There we go. Okay.
We're seeing presenter view right now. Yeah, you just have to switch it.
Sorry about that. All right.
There we go.
My name's Lamar Mayer. I'm a CTO at Spinchy. We're developing high power, high energy density capacitors for mobile storage. Okay. All good on the screen? Great. Okay, so what are the problems we're trying to solve? So power distribution with batteries, it's they can be slow to charge and slow to discharge, and they often have poor lifetime. Capacitors, however, charge really quickly, and they don't suffer from the recharge kinetics and delamination defects that batteries often suffer from. Supercapacitors also are fast and discharge quickly, but they suffer from low max voltage, and so they're not good for applications where you need hundreds of volts. Fuels, of course, slow discharge, and there's a lot of conversion required. And well, flywheels, that's kind of a special case situation. So we're trying to take new materials, advanced dielectrics, and change form factors and create extremely high power, high energy density capacitors. So our computations suggest that our capacitors will have specific powers that significantly outperform existing capacitors, supercapacitors, batteries, and lie in the specific energy space of around batteries with 10 to 1,000 watt hours per liter. So what are the enabling technologies that allow for these performance enhancements? So our capacitors, unlike existing capacitors, operate on micro patterned lattice geometries, as opposed to current capacitors often have electrodes that are just films, planar surfaces. And our capacitors make use of advanced dielectric materials that have dielectric coefficients that are orders of magnitude higher than conventional dielectric coefficients. Calculations suggest our mesh capacitors would outperform batteries and gasoline on a per kilometer per liter range by at least 10. So our team is founded by Irving Weinberg. Irving is a serial entrepreneur and physician and physicist. He has a history of developing very innovative products that have been used to image patients. I'm a materials engineer, and Ari Tuchman has served several C-suite roles in the past. He's a physicist. And some of our prior products have been PET scanners, CT scanners, and the reason we got into making capacitors is because we were developing imaging approaches, medical imaging devices in the MR space, and we needed really fast pulses to change magnetic fields. You get these really fast pulses from capacitors, but the existing capacitors were too large for the form factors we are looking to design for the imaging devices. And so we started looking through the literature, realized that there were lots of advanced dielectric materials that had not been commercialized, yeah, we're looking to move those into products. Yeah, that's it. Any questions?
Perfect. Thank you so much, Lamar. Well, that was it, right? Just want to make sure.
Yeah, that's all. That's our
Perfect. Perfect.
presentation.
All right, so we'll open up the floor to questions, and again, like Brian mentioned, whoever raises their hand first gets to ask first. Otherwise, I have a few. I'm happy to start. So in that case, I'll start. Can you talk about some of the government use cases that you guys have?
Yeah. So we just won an AFWERX Phase 1 award, and the use case there is directed energy. So the Air Force wants to be able to fly lasers around on drones and planes, and to do it to energy density per mass is significant there. And so yeah. Not only is energy density important, but also the ability to convert that energy to an electrical pulse for firing a laser is significant. And so the fuel and batteries require capacitors to upcharge before dumping all that current to a laser. And so if you can do away with other less dense energy sources such as fuel and batteries, and just use capacitors, that's advantageous to the Air Force. Yeah.
Thank you. All right. I think someone in the chat, I mean, unless one of the panelists has a question, in which case we're very open. But in the meantime, feel free to jump in if you do have a question. Someone asked in the chat how much you're raising, or if you're raising.
Yeah. I would say right now we're probably pre-seed, and would be raising in 6 to 12 months.
Okay, makes sense. All right, we have time for one or two more questions, if anyone has. All right. In that case, thank you so much, Lamar, for joining us, and thank you for the presentation. I really enjoyed it. Next up, we're gonna have Superseed. Feel free to start sharing your screen whenever you're ready.
Okay, perfect. Thank you. Just get this queued up here. All right. So we are Super Seed. We're a little bit different than most of the mix in here, but to keep it real simple, we are a green buildings materials manufacturer. Our goal is pretty simple. We want to make materials that perform better than what exists. We want to make materials that are better for our environment and ones that are done at a reasonable price. Where we're targeting is, the most ubiquitous building material, which is your sheeting products. So think plywood, OSB. That is a major component of deforestation. And in addition to that, it's a great place to put plastic because it needs to be waterproof, right? So what we are looking at right now is a really broken supply chain, from taking products out of forests, chopping them down, putting them in a massive facility, loading them up with formaldehydes and glues to ultimately create a product that doesn't last as long as it used to. Trees are getting weaker, building standards are getting higher, and what we're getting is a chemically laden material that still rots and warps and splinters when it comes within contact of any bit of moisture. So what we're saying is, how can we easily combat both of these problems? How can we divert some of the plastic that's entering our landfills and entering our oceans? And how can we transform that into a fully waterproof solution that displaces the need to chop down trees? So we're able to do that through a 3-step process that's really the core of the business. So first, we need to be able to prepare material that we ingest from, it's typically PIR, but we need to do a lot of additives to make sure that whatever waste stream that comes in is meeting the spec that we need it to in terms of ability for flow modifiers, impact modifiers, etc. Then we have to process that through a dye that allows us to optimize our strength to weight ratio, and also something that can be highly extrudable. And so with that, our first product is what we're calling the Super Seed Marine Board here. This is the world's first 100% recyclable, 100% waterproof, perfectly straight, perfectly stiff alternative to marine grade plywood, and as well as regular plywood and OSB. This will never warp. This is rot proof. This is just giving plastics a forever home, in the sense that we're going to outlast wood in any given condition, and do it at a high capacity in a very, very efficient footprint. So it's a massive market. We're focusing on boat building because there's just a need for it here. We're currently going through ICC testing. We passed the existing board right now, so we're ready to enter our fire rating testing, which is how we got involved with this program here. And then our goal is to really just tackle this massive opportunity. And the reason that we are, effectively arrogant enough to think that we have a chance combating in such a massive industry is because the typical model, as we spoke of earlier, is really broken when it comes down to the supply chain. All these steps are just another failure point. We're able to effectively take in PIR into one end of our plant, and then 120 feet later, create a perfect board of plywood. It's just in time. It's vertically integrated. It allows us to control our feedstock, and it allows us to put these plants near areas of high density, areas of that is density of need or density of excess material plastic. So we can spin these up, effectively producing in about 1/100th the amount of space that a typical lumber manufacturing plant would require. And that's not including forests. That's how big these plants are. So right now we're building product every day out in Phoenix, Arizona. We're getting ready to double the capacity of that plant. And then we'll raise sometime in March to go ahead and build plant number 2 somewhere in the Midwest, which will allow us to produce a lot of products, but without losing sight, the amount of forest that we'll be saving, it's about 100 acres a year of trees that we can save with what we're doing. This gets into a little bit more of what our carbon footprint looks like. But I think ultimately, the team here is a mission-driven team. We've all started companies together before. Jordan, COO, is on this call here. Developed a thermoformed jet ski that business sold, and we're all manufacturing entrepreneurs and trying to tackle this issue. So what we're looking for, really for us and through this network is that. We know we're in boat building. It's been great. We're working with the 3 biggest boat builders in the country right now. We are now looking to find unique opportunities, particularly where we think this will be a great product in some of the areas that we're focusing on with our Eagle Point funding friends here, which is basing. This is a great product for permanent or semi-permanent structures. We also have a product that is lighter weight, fully recycled, and it's great for crating. So we're looking to enter ourselves into logistics. And then next for us is we're experimenting with a few different additives inside of that part of our process that increase the impact strength, allowing us to make ballistic panels. Again, lightweight, low cost panels for that. So that's us in a nutshell. Appreciate you listening.
Perfect. Lawrence, go right ahead.
Yeah, thank you for the presentation. Can you talk a little bit, Sean, about what the marine market is like, where this is used, and what the alternatives are, such as fiberglass, and what's the cost of the main
So
platforms?
yeah, absolutely. Great question. So there's really only one or two specific marine plywood manufacturers in the United States. Those are Roseburg and Inland Plywood. That's your baseline, right? You want to buy that. You can look at MSRP, 1/2 inch 4x8. It's about $125, right? So we're retailing at that price. We just have the ability to go significantly lower than that at scale. It's a really strong gross margin business for us, but we can enter competitively there. Again, those are not strong. They're not, but the main thing this industry wants is a waterproof product. It's a $12 billion industry of people buying sheathing, or specifically marine sheathing, right? But it's very fragmented. So you've got those two suppliers here. Everything else is imported, typically from South America or Africa or Malaysia. So these are brands like Okume's and interesting hardwoods that are used in various laminate layers that have some inherent, and those become basically in your price point of $175 to $225 for that same sheet, but again, not fully waterproof. And then if you want something that's close to fully waterproof, you're now losing out on your structural backing. So those are going to be your composite boards, your FRP panels. You mentioned fiberglass. So fiberglass laminated honeycombs, no fastener retention, and you're not able to use them in the same applications as you would inside of a boat. And then on top of that, you've got your composite foams that are now with both of those products, you're in the $300 range, and at the top of that, you're at about a $600 range for the same 4x8 sheet. So we're coming in cost competitive, drop-in replacement. You're not changing any of your processes right now. Direct replacement to what marine plywood is offering today.
All right, Ariel, you're up.
Hi, so your feedstock here, PIR, this is basically insulation foam, yes? How much of that is there, and how do you intend to get your hands on it? I imagine the reverse logistics would be rather difficult.
Yeah, it's not insulation foam. We're sourcing it from really any place that has offcuts in PIR. Right now, our particular batches, bottle manufacturers, bottling plants. As far as scalability goes with the business, it is that issue, right? Recycling is pretty broken in the United States. If you go directly to, we've got plenty of folks that can give us feedstock, but there's like 3 middlemen in between that, right? So what we're doing is we're going directly to factories. We're working on these relationships either with a broker or by ourselves, or we're working with some of the waste recovery facilities and going right to some of the, the MRF sites themselves to learn how to grow that. We can easily, cover one plant with one factory location right now. So this process is repeatable. It's just a matter of us now, if our goal is to build 20 plants across the country over the next 10 years, just to really strengthen those relationships, because by the time you go way upriver and you're buying, fully processed, repelletized, recycled material, it gets price gouging, right? And we're trying to actually solve the issue. We're trying to buy flake. We're not trying to buy pelletized goods. We're trying to buy things that we don't need to put more energy in to just get the same product out at the end. We can take really raw plastic, add a few amount of elements ourselves with our own compounding. And I think that's what differentiates us in terms of the supply of, a reliable, true PIR feedstock.
Okay, so just for my own clarity here, when I hear PIR, I think polyisocyanurate. Is it a different
Oh no,
is
no,
something
PIR, just post-industrial recycle, just a broad umbrella term
okay.
for.
That
Yeah,
makes
yeah,
a lot more sense.
Yeah,
Because
yeah.
that is
I
a
was wondering
specific
where.
kind of plastic, and I was like, there is not that much of that. Okay.
Oh yeah,
So
no, good
in
question.
terms
Anyway.
of the actual plastics involved, you're talking about polyethylene, polypropylene, PET.
Yeah, primarily
Okay.
polypropylene right now, but we're experimenting with all sorts. Our goal is to have the widest envelope as possible, and then part of our process is really applying a scalable means of adjusting that for extrusion ability, right, and for strength. So that's kind of the heart of our business model. Yeah.
Okay. And
But
then
right
last
now,
question then.
polypropylene is our core material.
Okay. And then last question. What happens if you get PVC in your mix by accident? Is your system robust to chlorine and other impurities?
Yeah, it is. We don't want to extrude PVC because it's horrible, right? It's horrible for our the folks working the plants. It's horrible for the environment. But our machine is incredibly robust. So if we get a little bit of this and that in there, it's fine, which is again what makes us a different type of partner, right? In terms of really trying to solve the 400 million tons of plastic that are manufactured every year around the world and give it a home. That's our processes are built for that robustness to enable us to have a little bit more flexibility. It doesn't need to be as precise as buying clear PET specifically that's food grade, right? We don't have that. We didn't want to be constrained by those stringent qualities. One, because of gross margin, but two, just because of the overall impact that we can have.
All right.
Thanks so much.
Yeah,
Yep.
we have to be quick on the next two questions. Gerald and then Tito.
Yeah, thank you. Yeah, great presentation. I was also going to ask about the feedstock. So we are the manufacturer of polyethylene, polypropylene, PET, and etc. We are quite into recycling of it. So the question is, what kind of grade do you need in terms of feedstock? I think you mentioned post-industrial, and so if that's the case, do you need the pellets or you need? Yeah, so in terms of what kind of form factor?
So we're buying raw flake, 1 to 3 centimeter flakes. If we can keep it consistent at 1 centimeter, we're buying them by the Gaylord, and they get shipped to our facility, and we can extrude right from there. So we're really just raw flaked. If it's washed, that is a huge plus, right? So we're looking for washed, chipped flake delivered to our site. We also have the ability to do the grinding, but this is frankly, it's just a easier way to transport it. So it just comes down to volume. So whatever the highest density means of transporting that raw flake to us, ideally, if we want to get into the specifics, we're just looking for something with a very low melt flow. And that's ideal. Polypropylene, low melt flow, raw flake would be ideal use case. And then we, go up and down from there.
Okay, super quick follow-up. So what's your core technology? Is it the resin that you put into a formulation?
It's the manufacturing process, it's the design of the die, and it's also the formulation and the formulation process. So all three of those things are what we've patented. And all three of those things in unison will continue to develop more IP around that. But that is the intent, is that no one's been able to find a means to actually make a structural ICC rated, right? Hurricane windproof rated board out of sheathing board out of recycled materials. So that's, we said, how can we do that? How can we protect the IP around that?
Okay, thank you. We can take it offline for further discussion. Thank you.
Sounds good. Yep.
Sure. Tito, last question, hopefully fast.
Yeah, I'll keep it short. What's your go-to-market strategy? Are you trying to distribute, are you going to distributors, or are you trying to sell, cut middlemen in that sense as well? Because I've been a lot in the industrial supply space. And I see that middlemen take a big cut on production, not production, but just the sale of any material.
Yeah, when you're dealing with OEMs in our space, so our go-to-market, to be very quick, so go-to-market answer it is OEM boat builders in the marine space. That's our go-to-market. Those folks already buy direct, right? So they'll buy from the 1 or 2 producers of marine ply, or the 1 or 2 producers, or 5 or 6 producers of marine sheathing alternatives, that really high cost, waterproof stuff. They buy direct anyway. So for us, we go through a very similar sales motion with them that'll enable us to justify scale and actually bring the company up to a break-even standpoint. From there, our goal and our intent is to continue to reduce COGS, build a product that is going to enable us to enter into construction, And then from there, that's going to be all distribution, right? And that's really the only way you make it in construction markets. You've got three major players, right? Everyone knows Home Depot, Lowe's, and Menards, right? So we've got we're starting smaller with regional specialty lumber distributors today. And then as we effectively earn our stripes, get our volumes and earn our way into the right wholesalers with enough, volume production available to commit, we'll jump into distribution long term. But right now it's all direct, and that helps us, refine our product and our approach, and know our customers and know all the ins and outs. So that's where the go-to-market lives today.
Cool. Thank you.
Yep. Thanks everyone for the questions.
Thank you. Yeah, thank you, Sean, for another great presentation. Feel free to leave your contact info.
I will do that. Thank you.
Awesome. Next up, we have Aclarity presenting. Feel free to start sharing whenever you're ready.
All right. Hello, I'm John Tracy. I'm the head of business development for Aclarity. We are a PFAS management, PFAS destruction company. We founded the company around electrochemical oxidation. The company was founded out of UMass Amherst back in 2017, and we've scaled up this electrochemical oxidation technology to the point where we're at a technology readiness level of 8/9 right now. We've put our first commercial system out into the world. We've done multiple years of pilot deployments prior to that. And what we're doing, we're focusing on the breakdown and conversion of these forever chemicals into fluoride ion, CO2, things like that. We focus on water as the contaminated medium that we're doing our destruction technology in. The company is led by folks out of the water industry, veterans from other clean tech startups, and some folks out of the large engineering firms operating in the US. We've been through Series A and an earlier seed round. We're probably 6 months away from beginning a Series B round of investment and fundraising. So where we fit in this whole PFAS management space is the block on the bottom right here, which is different forms of destruction of PFAS contamination in wastewater streams. Electrochemical oxidation, as I said, competing with some other types of destruction technologies. The different technology companies in that part of the space focus on the problem in different ways. But also important in all of this are other technologies which do capture of PFAS onto media and then disposal of that media or incineration of that media. There's a whole measurement and monitoring space that is evolving, trying to get from weeks of time to get results to days or hours, or even at some point online PFAS monitoring, but the industry isn't there yet. And then there are various concentration technologies, especially for things like groundwater remediation and that, where it makes sense to concentrate the PFAS into a smaller volume than what you would see in a large groundwater remediation piece. We work with those technologies as well. It's all about bringing the right stream and volume per day to a destruction technology. How does our destruction technology work? What we do is basically break those carbon fluorine bonds. That's what makes PFAS compounds so difficult to break down over time in the environment, or makes them uptake into the human body and not be able to be broken down easily. We're using free electrons that we generate in sets of electrodes that are in the systems that we manufacture. This is called direct oxidation, using these free electrons to break the carbon fluorine bond. Along with that, our technology produces a lot of other oxidants, other types of free radicals that they break down the competing organics that are in the streams we deal with. The company got its start treating landfill leachate, which is almost legendary in its difficulty as a wastewater to treat. The combination of indirect oxidation, breaking down all the other organics that are in the stream, and then the direct oxidation, which breaks down the carbon fluorine bonds and the PFAS. Those are the key pieces of the puzzle. How is the technology different? The technologies like ion exchange media or activated carbon, they capture PFAS compounds into this media, into the active sites in these media, and eventually become exhausted and have to be replaced. And then the exhausted media is either landfilled or sent to incinerators, right? You're kind of taking the PFAS from one medium and moving it into another. There are concentration technologies such as reverse osmosis, nanofiltration, or foam fractionation, which they help isolate and remove the PFAS from the bulk water stream. But then in that concentrate, you've got to deal with it in some way. And then there are the other destruction technologies, which by and large have a higher energy footprint or require a lot more electricity or thermal energy to do the job that we're doing with our technology. How the company has developed its technology over time was early days, we were producing single electrodes and running small tests at lab scale to basically demonstrate proof of concept. Yes, can we destroy PFAS in your particular waste stream? Check that box. We've moved into field deployments of the technology, going from one electrode in a very small reactor to systems with 10 electrodes inside of a larger reactor. These field deployment systems, they can process 1 to 3 gallons per minute of water on site at a landfill or an industrial site or a groundwater remediation site. It's a great way to prove out the technology over time. Finally, just earlier this year, we released and put into the market our first commercial system, which is 8 of these 10 electrode reactors and the associated power supplies into a commercial system that can run at up to 30,000 gallons a day, or about 120,000 liters per day, and treat industrial streams at the effluent sites.
30-second warning.
Thank you. Yeah, this is the last slide actually of concern. A little bit of data on the right showing both PFAS breakdown, 99% or more reduction of the core 6 PFAS compounds that are regulated in the US. And then we also do a good job on ammonia and COD reduction, going from 800 or 1,000 parts per million to single-digit parts per million in our systems. What we're looking at now are to move into other spaces beyond the landfill leachate and the early groundwater projects that we've been involved in. We're moving into conversion of firefighting, fire suppression foams from fluorinated PFAS containing to non-PFAS containing, work in the semiconductor industry, work with the EV battery recyclers. We're basically trying to queue up as much pilot testing and early commercial projects in those spaces as we can, having already taken on and having a good amount of work with the landfill operators. Really, with that, I'm happy to take on any questions.
Thank you so much, John. All right. As you guys already know, we'll answer questions in order of hands raised, or if you can't figure out where the button is, just feel free to pipe in. So give it a second for people to
I have a
get.
question.
All right, go ahead, Lawrence.
Hello, thank you for the presentation. Could you comment a little bit on how energy intensive the technology is, and also how do you, what's the composition of the cells, like the electrodes, and how do you keep them from either corroding or breaking down?
Yes. So this version of electrochemical oxidation is it's using anode and cathode materials that are very, very durable. The current cathode design is a titanium-based alloy The anode is a mixed metal oxide, also featuring a lot of titanium. These have a multi-year service life, so it's not like a ferric type of electrode situation like you'd see in other water treatment technologies using electrochemical processes. Good long life. The energy usage on a difficult water like a landfill leachate, it tends to be in the order of 50 to 100 watt hours per gallon being treated. So for one of our commercial systems, that equates to about between $50,000 and $100,000 per year worth of electricity to treat, say 15,000 gallons a day are good rough numbers to use. So it's not incredibly energy intensive. It is the highest part of our operating cost per year. The second being spare consumable parts and those electrode replacements about every 5 to 10 years.
Thanks, John.
You bet.
All right, I have a question.
Go ahead.
John, how does it compare to, let's say, other electrochemical processes in price wise view or efficiency wise compared to other electrochemical, not the energy intensive ones, but
Right. This does tend to be, I guess, lower on the spectrum as far as energy usage per amount of PFAS destruction goes. There are technologies such as using a plasma being generated to break down PFAS. That tends to have to be in fairly clean streams, though. And then there's a supercritical water oxidation process, which that means bringing water to very, very high temperature, right, far above the boiling point, 374 degrees C, and very high pressure. I can't remember the pressure number, but like you would see in a utility grade steam generator, which has good properties for oxidizing and breaking down PFAS, but it's very, very energy intensive and expensive. We are, let's see, as far as other electrochemical processes go, it's about the same energy intensity as, say, electrocoagulation you would use to do treatment of wastewater prior to membrane systems, that type of a process. I'll put my my contact info into the chat in case anybody wants to follow up after this.
Yeah, thank you so much, John. You already know the drill. Perfect. With that, we're gonna give the floor to EVtronics. I believe Dan and Paz will be presenting. Whenever you guys are ready.
Let me share my screen here.
Sure.
Okay, our company, Falcon Green Energy, EVtronics is an earlier product, so I'm sorry for that naming convention. We're a smart grid development lab here in Austin, Texas, and the smart grid distribution transformer is in advance of the most common piece of hardware in our electric infrastructure. If you look at the image at the bottom left corner there, that's a ground mount 30 kilowatt transformer. You'd see this at any home or office building where you got an electric meter, an electric service, you have one of these transformers available. This is from Nikola Tesla's advancement of transmitting high voltage over great distances down to the usable voltages of 120 or 240 volts into our home. That was a ground bounce. We also, this is probably more common to see the pole mounted cans in the behind our homes and businesses. This is a 3-phase system with 3 cans. So this distribution transformer is a very common product in our electric infrastructure. and has not changed for some 120 years. They're filled with mineral oil for cooling, and we bring quite a few advancements to the table with our smart grid distribution transformer. It's a critical part. You can't have electricity without one, so it's a necessary part of the system. Here's another image of a larger one. That's actually a 100 kilowatt system, which would be for an office building. Our innovation is solid state electronics. We convert the alternating current from AC to DC back to AC. And this allows us to create a micro utility at the customer site with perfect voltage and perfect frequency, even better than the utility can provide. And then in the middle here would be a capacitor or battery that provides backup when the utility is gone black. So that's it in a nutshell, but there's a lot more to it in terms of what we can do with it. We call this a BESS, or a battery energy storage system, that's becoming much more commonplace in our electric grid to solve problems. Typical size for our system would be 20 minutes, but it could be scaled down to 5 minutes to save capitalization cost, or even to hours, depending on how much reserve capacity the customer or the utility wanted. This is equivalent to a UPS, or an uninterruptible power supply that you might have on the floor next to your desktop computer. It just works for the whole building. Now, what we call BASS, batteries as a service, is part of the business model that we can take one of these smart grid distribution transformers and virtualize it and pool or gang them together. So there might be a 10 kilowatt hour system at one home. You put 250 of them together in a neighborhood, you got 25 megawatt hours of energy capacity, which is a usable amount for the utility. So when the utility is down, it powers the house. But when the utility is up, the utility can make use of the battery and do other things with it, called ancillary battery services, to solve their problems of frequency regulation, load management, power shaving, are all possible by this distributed system. So the business models but behind this are fairly compelling. We can do additional things with it. This is a good energy hub to bring in solar panels on our rooftop of our home or building. Small wind systems as well can be integrated into it, and other generation elements besides the local utility can be coupled into the smart grid distribution transformer, serving as an energy hub. And this question?
No, just a 30-second warning.
Okay. So wind and solar can be integrated. The market size for this is huge. Again, this is a very common product. Anytime you have electric service and a meter, you have one of these distribution transformers. And we believe that just a small 1% of market capture makes this a very successful company. We're seeking just a convertible note at this point to develop three typical sizes of 30 kVA, 75 kVA, and 150 kVA for $1.5 million in a convertible note. I'm an electrical engineer. I've been involved with numerous energy projects and worked for Los Alamos National Labs. It's my first job out of university. So I have some experience in this space as a electrical engineer and analog digital designer. My partners, Paz Reinstein and John Shanahan, bring a lot to the table in terms of their connections to capital. So I wish my email address was on there. I will tell you that now, or put it in. Let me put it in the chat box.
I just put it in, Dan.
Thank you very much. So we have some intellectual property in here as well. So there's some IP that makes this unique. Any questions?
Sure, let's open the floor. Thank you. Thank you so much, Dan.
Yeah,
So I guess
Dan, I was going to ask you about the intellectual property, so you can expand on that.
The what now?
The intellectual property you were just mentioning.
The switching transformer and going from AC to DC back to AC, this doesn't operate at 60 cycles per second. It operates at either 50 to 100,000 cycles per second. So the transformer size is much smaller at the higher frequency. And I have a unique design of, right now transformers use what's called a E stacked ferrite laminate, that we would use a closed ferrite laminate, an H shape rather than an E shape, if you can visualize that by the shape of the letter. And we have are proposing a stitching machine. The reason that they're open-ended laminates is that's the only way you can wind the wire around it. So as soon as it's a closed laminate, it's difficult to wind the wire around it. So with a stitching machine, we can engage in that manufacturing process. This adds about 5% efficiency to the conversion of the transformer. Now, 5% may not sound like a lot, but over the 50-year life of the transformer and the escalating cost of electricity today, in any smallest increase in efficiency equates to savings over the long term. There's also a lot of software in the background to make it do these sophisticated battery as a service functions. There's easily a dozen different uses for a battery that the utility can make use of.
I see that there's another question in the audience, but they should ask it through the chat or the Q&A so that we can see it. In the meantime, Dan, you want to talk about some of the government projects you've been working on as well?
Well, we've recently, with the help of Eagle Point, have actually applied for a DOE grant. The Department of Energy has a program called FIT, F-I-T-T, which is the Future Infrastructure Transformer Technology. And we meet 98% of the goals in the FIT solicitation to make an advancement of a transformer. So the U.S. Department of Energy has a vision for this, and we think we meet that vision. In terms of batteries, which I claim are growing in their use on the grid, Texas uses more air conditioning than anywhere in the world. And last week, we had a record high electric use in Texas, 86 gigawatts. And the battery systems in Texas were paid a premium of $5 a kilowatt hour. That's 100 times the retail price of electricity. So when batteries kick in to keep our grid from collapsing, it can be a lucrative proposition for the developers of these battery systems.
Sure. Yeah.
The question was how does it integrate with local providers, with local energy providers, and does it have to pass certain regulations?
There will be some certification on it, but any utility in the world is buying these transformers today. There's another driver as well. There's been a supply chain issue on distribution transformers where it may take 1 to 2 years to take delivery of them for the growth of the electricity around the world. Many of these products are coming from China today, and with the smaller form factor, we plan to manufacture this here in the United States and shorten the delivery times.
Awesome. Awesome, Dan. Thank you so much for the presentation. And I know that Paz already put the contact info in the chat, so that's already where it needs to be. But thank you for that. And we'll move forward from there. Up next is Adrian, and Kenny will be presenting. Kenny, the floor is yours whenever you're ready.
Cool. Can you guys hear me?
Yep.
All right. Hey guys, my name is Kenny Lee. I'm co-founder and CEO of iGen, and our mission is to regenerate Earth with robotics and AI. So we have satellites in space that you guys all know the logos behind, the drones in the air as well, huge markets. And we have fixed sensors in the ground, which is ubiquitous and a commodity. But what we believe is really missing is what we call terrestrial satellite rovers. So ground-based rovers that are self-sustaining, 100% solar powered, that is a communication network that can talk to each other, and then that has the ability to carry payloads such as sensors and actuators. So what we built was the iGen robotics platform, which is 100% solar powered, and that is the biggest constraint of the innovation that we've built. It is efficient in AI, it has connectivity built in, there's autonomy, and it is all solar and battery powered. It also has modular functionality, so then you can swap out the actuators and the sensors on the robots and different cameras for sight and seeing. We have plans for platform expansion, what we call fusion. So the first generation of the robot is called Element, and then you can actually fuse them together and create a wider robot, call it Fusion. We already have that in the works right now in the build. And in the future, we will integrate drones into the bay of the robot as well, so it could launch drones. And that's part of our core IP as well that we've been granted. I'd like to play a video here while I talk. So there's multiple industries and use cases that we can go after. And I've listed some of them below, such as environmental, monitoring wildlife, air, soil quality, infrastructure, such as surveillance, renewable energy sites, such as solar and wind, construction, such as site surveying, land management, monitoring for wildfires, risks, restoring degraded soil. There's a great project in Africa called Just Dig It, where it actually digs, and then you could restore the land by capturing water. Demilitarization zones, such as landmine detection and mitigation, and last but not least, agriculture. And we looked across all of these industries, and all of them are actually serious contenders, but we're going after agriculture first as our beachhead. Why? Because it's 40% of land use is agriculture. So the first problem we're tackling is empowering modern agriculture or farmers for the human and the planet. Couple of notes that I want to highlight here is that 97% of land is rural land. We're spraying a bunch of pesticides for agriculture, which we'd rather not. And then last but not least, agriculture is about 25 to 33% of global carbon emissions. And maybe play this as well so you can take a look. So within the agriculture industry, we've been able to test in the most extreme conditions. It was 100% outdoors, fighting mud, rain, flood, storms, high winds. And we built about 50 of these throughout the previous growing season. And so cumulative, we've tested over 10,000 hours across 3 months. That's one growing season. And just to give you a perspective, a tractor runs anywhere between 400 to 600 hours a growing season. And we put in over 10,000 hours on our little babies. The roadmap, we're starting out with chemical reduction with through mechanical weed control. And this is a problem that farmers have asked for. And this is a real pressing need for them, specifically around herbicide resistant weeds where chemicals are not working as well as they used to. So we're addressing that, that problem head on. We're going after AI and data analytics as well within agriculture. And then last, our future vision is terraforming. How do we actually reform the land, store the land to be healthier? So of course, as iGen, AI is within our name. So what you're seeing here is each of these sizes is anywhere between 120 to 160 acres. Just to give you an idea, an acre is about roughly the size of a football field. So each of these map is about over 150 acres. And then on the left-hand side is what our robot has actually collected throughout the growing season, every square inch of that land. And on the right is predictive modeling of where we would predict crop growth as well as weed growth. And you can imagine if we mounted other sensors for disease and pest detection, we'd be able to accomplish different other things. And of course, ChatGPT LLMs is a big thing. So we also wrapped our service around that. So we're able to go in and ask questions about the farmer's land and the operations. And we believe that this is a first of kind where you get minute by minute update into a language model. And so that farmers could actually ask questions as well as get alerts if you set those type of monitoring services in place. We believe that this is a perfect opportunity. There's a convergence happening. Cost of AI, autonomy, and solar is dropping exponentially. And then the edge compute efficiency is going way up. So we're taking we're riding the wave, and we believe that this is a perfect opportunity for a product like this. We're fast to execute. We raised a Series A in late 2022, and then since then we designed, built 50 robots, launched an app, deployed on customer farms in Minnesota and North Dakota, got a bunch of hours in, and then we collected a ton of data. So the ask, we're looking for non-diluted capital. None of this is cheap. It's very expensive. And we're serving a broad market where it's a pillar of human society, and their margins are low. So we do not want to be extractive for them, but we think that could be interesting. I mean, what could be interesting is partnerships where you see other use cases for robots like this. Think of it as a platform in different industries. We're very interested in different ideas and companies and corporations that are different visions for a platform like this. And last but not least, if you're an investor, of course, give us a call. We've been featured in, we've been highlighted in a few, I don't take this too seriously, but you know, we've been on the intertube somewhere. And then if you're interested, come and regenerate Earth with robotics and AI. We're a team of amazing builders from different various backgrounds, and you see my email on the bottom left-hand side. Thank you.
Perfect. Thank you so much, Kenny. All right, feel free to jump in. Whoever has the first question, go right ahead. All right. In that case, I guess folks are still warming up. But Kenny, you want to talk a little bit about more of, well, it looks like someone asked in the chat. What do you do in GPS denied environments for navigation and avoiding collision?
Yeah, that's a really good question. Well, I'll answer that in twofold. LT denied is a frequent question, and GPS denied as well. We've experienced this in some of the areas this year. What we're planning on doing is setting up what we call a Nexus, which is a base station, and we're using Starlink satellite to connect that area, and then our robots will be equipped with mesh networking, specifically the Halo network. If you haven't looked into the Halo, it's actually really interesting. HALW. And then each robot will be a node in a mesh, and they can be about a kilometer apart and still talk to each other. And as part of GPS, you could get GPS in through an RTK-based system, as long as it's connected to the internet.
All right, Sam, go right ahead.
Yeah, Kenny. So you guys raised Series A. You've done some pilots with ag customers. Can you just talk about how that went? Did you kind of figure out the value proposition? What is the business model looking like with that kind of beachhead market?
Yeah, great question. So we niched way down into a crop called sugar beets. And sugar beets is over 50% of our sugar comes from beets. And I didn't know this before I started. And it is very concentrated in North Dakota, Minnesota area. So we are the sugar beet weeding robot guys. So we were on the cover of Sugar Beet Growers magazine, a couple months ago. So that's our beachhead. But we are going after the big market, which is soy. So the way that we think about the growth trajectory, we're going after sugar beets, but it is a rotational crop with soy. And so we believe that there's a huge market there, not only in the United States, but globally. But another market that we've just validated is cotton. And most of cotton is grown in Texas and the Mississippi Delta region area. However, premium cotton, it's called Pima cotton, is actually grown in Central California. So one of the biggest growers we met last week, and he wants to start pilots as soon as possible.
And are you finding that your pilots have shown kind of a worthwhile value proposition to your customers? Is it worth it for them to use your robots to do the weeding, etc.? Can you talk a little bit about that?
We've been invited back for next year, so I think so. I think so. And you gotta know, Sam, that where there's herbicide resistance, the only alternative, because chemicals are not working, is manual labor. And in these regions, manual labor just does not exist, no matter how hard they try. I mean, think about global North Dakota. Migrant labor just does not migrate toward that regions.
I think we have time for one more
Do you
quick
have,
question.
yeah, Kenny, do you have some images of the weeder function and how it works? Is that what you did in June, or was that more data gathering that you were doing in that June pilot?
Let me see. Do we have time?
Yeah, if you could keep it to like 30 seconds, but yeah, if you want to show the
30
video.
seconds. Yeah, 30 seconds. Do you see my screen?
Not
No.
currently.
Hold on. That's it. And so the way that farmers actually think about our robots, which is actually pretty cool, is that because it is light and small, it's about less than 150 pounds. They don't think about it as a big ag equipment. They think about it as almost like manual labor. This manual labor just happens to be a robot rather than a human. And so you may think that farmers like CapEx purchases, and then that's what they're used to. In this type of situation, they almost see this as, rather than calling a person to come and weed, they're calling a robotics company to deploy their fleet of manual labor robots. But with that being said, I think there are other really interesting use cases for the robot as well, which is why I'm on this call. And please give me a ring if you have any ideas.
Sure. All right. Unless anyone, okay, I think that's the time we have, but thank you so much, Kenny. As always, it's a really interesting technology and really great presentation.
Thank you.
Absolutely. And with that, we are moving on to our second session. The panelists from the first session, feel free to stay on, but there's going to be some new panelists in the second session. We're running a little bit behind on time, which is fine, but we're not doing intros. But what the panel can do is that when you ask a question, feel free to just remind folks where you're coming from and who you are so that they know who they're answering so that they could be as precise as possible with the answers. And thank you everyone for joining, and thank you for everyone in the first session. All right, with that, we're going to go straight to Omi Motors. Feel free to start sharing your screen whenever you are ready to go.
Okay, thank you, Asher. I will share my screen.
For it.
Okay. Okay, so we are OMI Motors. We are an electromechanical innovation company. We have been engineering complex problems since the 1998. We built and design and manufacture powertrain components for the power sports industry, especially DC motors and electromechanical components. So we are here to invent, manufacture, and deliver. We're a well-established company having customers in the Fortune 500, Fortune 500 companies. Basically, we specialize in electromechanical DC motors and specialized motors, starter motors, proportional valves, flow control systems, electronics. And we are now focusing on EV and hybrid platforms. We want to bring electrification in the power sports industry, and there are many challenges with that. Some of the companies we work with, so Polaris Industries, Harley Davidson, Arctic-Cat. So these are our biggest customers. We supply most of their starter motors and other DC motors and other components in the powertrain, and we have been doing so for the last 20 plus years. What we're working on, we're working on the electrification in the power sports industry, and there are many challenges with it. 5 of the biggest challenges is the battery technology and energy density, because these vehicles are small and they are using very demanding environments. The other issue is range anxiety. These vehicles are used in mountains and remote locations. The durability, the use cases, the vibration, the shock using these vehicles are very high. The cost, of course, the components to electrify one of these systems are very high, and also the production. These are lower volume vehicles than compared to automotive. The supply chain is also a big issue because relying on the Asia markets, the Asian supply chain has been a pain in the last 3 or 4 years. So what we're working on and our solution is a hybrid powertrain and battery technology. So we are working from the chemistry. We're optimizing everything from the chemistry in the battery to the motor, and we are developing everything in between. So we have, I forgot to say, we're established in Texas, but we have a manufacturing plant full of engineers. In China, we have battery research lab in Southeast Asia. We have operations in Mexico, and we are opening a manufacturing site also in Mexico, so we can manufacture products in the North American space. So in our research lab in Southeast Asia, we are working on battery chemistry, and we are working on optimizing from the chemistry so we can have a better use case for the power sports industry. And we are also building the motor, we are building the gears, we are building the electronics. So our goal is to have a full hybrid powertrain system that we can offer in different industries, for the agricultural, for the military, and for the commercial and recreational spaces. The first prototype of our vehicle is going to be ready in Q4 this year. We already have the motor, we have the batteries, and we are going through testing. How we are tackling these challenges? Well, we have proprietary battery chemistry. It's patent pending. We have a battery chemistry that have higher energy densities and has higher charge and discharge rate, while we have the lithium iron phosphate technology or chemistry that keeps prices down. Range anxiety, well, we have higher energy density in our batteries, as I said, but we are also focusing on hybrid technology that helps with that range anxiety. Durability, we go through thorough testing with all our systems. We make our systems up to standard, military standard, And we have more than 24 years of experience manufacturing components that are used in the powertrain, in the power sports industry. To reduce cost, we have a full vertical in-house design. From design to production, we can do everything. And the supply chain, we have full production in Asia and in North America. So a little bit about our battery chemistry. We have our patent pending novel approach to produce safe batteries. On the graph on the left, you can see the black line is our benchmark high quality, high energy density LFP battery. And the other graphs are what we have achieved with different samples of our technology. We are currently on the green line. So we have surpassed the performance of the commercial high-grade LFP batteries, but we have still work to do to narrow the performance of this battery. The market is growing. There's an increasing adoption of hybrid vehicles globally. There is big opportunities in commercial and military, but also for fleet vehicles for governments and municipalities. Also, the recreation market is growing because all of the benefits of having a hybrid powertrain or electric vehicles. Our edge, well, we have a proven track record of delivering high quality and reliable products. We have strong partnerships with tier ones and OEMs. We already have a customer base. We are a healthy, profitable, and established company. And our integrated approach from product to design, from designing to production, is what gives us a lot of advantage in making our systems more efficient. We're, as I said, manufacturing in North America and in Asia, and we are very agile, very fast, very dynamic to make changes and bring products to market. This is where we have operations, the US, China, Southeast Asia, Mexico. Just a quick overview of our team. Nick White, our CEO. I'm the Chief Technology Officer, and Tim Appleton is our Chief Operating Officer. The investment we're looking for an investor that can help us expand into new markets and take OMI to the next level. We are looking for 16 to 20 million. We are looking for a partner that is willing or is looking to help us revolutionize the future of transportation, the power sports industry, and wants to invest in a well-established company already with customers, which is profitable and very healthy. So if you have any questions, just let me know.
Thank you, Luis. All right, opening up the floor. Feel free to chime in if you can't find the button, or feel free to raise your hand and we'll get to it in order asked, hopefully. All right, so I'll ask a few here. Can you go through some more use cases?
Sure.
Some things that folks might not necessarily always think about.
Sure. For instance, we have a customer which we are developing and designing a vehicle for them. They are using it for border patrol. They have these vehicles that are for border patrol, for surrounding, and they have an internal combustion engine and our hybrid powertrain. So they are able to extend the range of the vehicle, and they can have different uses or use modes. Like, for instance, we have a stealth mode where the electric motor runs and the vehicle doesn't make any noise. If they want to be like in a stealth mode, we have hybrid mode, we have high power mode, we have only internal combustion engine mode. So it's a very dynamic vehicle, and the way that we design our system is that it's very flexible and it can be integrated with basically any chassis design with a few modifications. So we can integrate it with different internal combustion engines. So we can use it with either diesel or gas engines.
Good. Sure. Absolutely. And then Yeah, I mean, we do have, okay, Tito, go right ahead.
Yeah. One question, Luis. Is your product, so Omni, I've heard of you guys before for, like motor solutions, but are you guys, your new product is a full vehicle? Is that where you're pitching here?
No, we are not planning to build the whole vehicle. We are developing just the powertrain from batteries to motor. We think our solution is very flexible and can be integrated with other customers. Also, we don't have the supply chain, we don't have the infrastructure to support selling vehicles in a very in a profitable way across many countries. So our plan is to develop this powertrain and then partner with other OEMs that are willing to adopt it. We are already in talks with OEMs. We have been supplying the OEMs I mentioned, and we are already discussing how to implement our powertrain and our technology into their vehicles. So what we're trying to do is finalize, have this proven system, and also expand the market. We are already established in the US, but we want to expand into different markets, look for other OEMs who would be willing to work with us and are interested.
Great, thank you.
Perfect. Perfect. Thank you so much, Luis. Thank you for the presentation. Feel free to leave your contact information in the chat so that folks can contact you post event.
I will.
Perfect. Beautiful. All right. Next up, we have Maverick Biometals. Feel free to start sharing whenever you're ready.
Awesome. Can everyone see the screen?
Yep.
Awesome. Cool. So thanks for joining us. I am Eric Herrera. I'm the co-founder, CEO of Maverick Biometals, and a little bit of what we do is essentially expanding metal production with biology. So we're not a biomining company, we're a mineral processing company. And essentially what happens is mining companies are very, very good at digging up the ore, very bad at actually processing it and actually extracting the metals, which is why most of the ore produced in Australia and in Canada, which are the world's largest producers of lithium, for example, it all gets shipped to China. China controls around 98% of the world's lithium refining capacity from hard rocks. And so we're trying to change that with biology. So a little bit about us. My background is actually in medicine. I used to work at the Department of Defense developing enzymes to decontaminate chemical warfare agents. And I figured out that the chemistry could also be applied to break down plastics or silicates. And so that's how we adapted military technology to the civilian market. My co-founder, Jesse Evans, he is the entrepreneur. He handles all the business. So pretty good yin and yang, one to make, one to sell. And we just finished our seed round. So we have strong financial backers from Anglo American. They're amazing. They're a very large mining company, as well as some other strategics, and pretty good amount of grant funding from the Department of Energy and the city of San Antonio, where we're based out of. And so we're focused on lithium-bearing minerals first, specifically spodumene clays and lepidolites. Lepidolites are like micas. And these are where most of the world's lithium comes from, as opposed to brines. And these are all silicate matrices. And essentially what happens is they're dug up, they're expanded by heating it up to about 1,600 C. That expands the crystal structure. And then you do strong cation exchange with very strong, very concentrated sulfuric acid. And the process is terribly inefficient. So we changed that. And we're also going into rare earth elements and copper next. And so the extraction on our end, the way it looks like is the minerals are crushed to a fine powder, and that's already the industry standard, to about 150 microns. We mix it in a tank with water. That water has a buffer and it has our enzyme. And what it does is it starts to burst apart at a molecular scale the lattice structure of these minerals. And in doing so, what you generate is a polymetallic brine, and the silica, which polycondenses back into silica gel. absolutely pure silica gel because all the metals have been extracted. And this is actually what it looks like in real life. This is hectorite. It's a swelling clay, 30% with water, and you can see that it's essentially solid. This is the same amount with our enzyme at a micromolar concentration. So you can see how the metals have extracted on the top, and essentially the bottom is just pure silica. And what we're left with is goop. So that goop essentially allows us to extract all of the metals contained in that mineral at ambient conditions. The entire process takes about 46 to 48 hours and uses about 98% less energy than the traditional acid roasting. And what our secret sauce is essentially enzymes. We design enzymes that they're hydrolases, but they bind specifically to that crystal structure, bind to it, break it apart, and then move over to the next stage. And essentially are reused in the presence of water and metal. And that allows us to produce this polymetallic brine, the silica gel, and the metals then we just essentially extract from the brine. This is a very, very concentrated brine. It's about 400 to 700 times more concentrated than the lithium brines in Argentina and Chile. And so far we've tested around 80,000 variants in our lab here in San Antonio. So acid roasting, the traditional method, super inefficient, toxic byproducts, high amounts of energy, greenhouse gas. It's about 1.5 tons of greenhouse gas for every ton of ore processed. It's really not sustainable. And more than anything, it is incredibly inefficient. First pass efficiency of 73.2% max for lithium extraction. Ours is about 98.2. It's also a little bit cheaper. It's about $200 cheaper per ton. So cheaper, more efficient, better for the environment. We really try to make it a no-brainer for companies to use our process as opposed to acid roasting. And like I said, higher efficiency, lower energy, very, very little waste, if any. Most of it gets reused, and circular water usage. With traditional mining, you also get a lot of waste rock and acid mine drainage. Our process works at a pH of 5 to 7, very, very close to neutral. And we also generate an amazing byproduct, silicon. So this is the first silicon that's been produced biologically, semiconductor made with biology, which is pretty great. And most importantly, at commercially viable prices. And so we've tested about 15 different minerals in the lab, proven at 1 to 10 liter scale, and we're scaling up to about a 1,000 liter reactor, about 900 to 1,000. And that's with a lepidolite producer in Canada. Over 98% extraction efficiency for lithium, and we're moving over to the rare earth elements soon. And we do have a pretty good amount of patents as well as trade secrets to produce the process. What's not on here is actually a side reaction that we figured out almost by chance, that sometimes if we keep one of our bacteria in the brine, we can actually make microspheres. Some of the minerals had a lot of uranium and thorium, and we ended up making uranium microspheres from 50 to 75 microns in size. So also pretty interesting. We're not sure what to do with those yet. So open to suggestions. And very strong industry need and interest. So we've been around for about 2.5 years. We are working with 3 major mining companies, actually scaling up with them. 5 junior mining companies where we're doing their initial ore validation for their sites. And then the MOU for the paid pilot and demo plant, the one to be built in Canada, and potentially another one in Brazil. And lastly, we also have our own deposit. So we have the prospecting permits for about 8,000 acres in West Texas. And this is a very interesting deposit. It's a rhyolite. It's a silicate that contains not only high levels of lithium, but very high levels of rare earth elements, specifically yttrium and dyspropium, as well as high levels of uranium. So this is an untapped resource, and we're seeing, does our technology make sense to actually exploit it? And so far, lab scale tests are showing yes. So yeah, our ask is really, how can we get more non-dilutive funding to help us with scale up? And then if anyone has any ideas, any offtakes for the potential uranium thorium products that we can produce. everyone wants to buy lithium. Uranium and thorium are a little bit harder to sell. But yeah, thank you. Open to questions.
All right, Lena, go right ahead.
Hey, Eric. Thanks for the talk. I know it sounds like you've scaled up to 1 and 10 liters so far. What's the timeline to be able to sort of scale up to mass manufacturing here?
To mass manufacturing, we're still talking a little bit with the actually yogurt producers to offtake their waste product from the milk production, from yogurt production. And as soon as we have that done, essentially the science is done. Now we go over to Fluor. Fluor is designing the actual reaction facility to build at large scale. It should be in about 1.5 to 2 years as when we want to start producing at industrial grade, essentially industrial amounts for sufficiently for a mine site. Probably in Idaho, and then another plant in West Virginia following after that.
Okay. And then one more question, if it's okay. Just trying to get a sense of cost comparison here. I know like China does the majority of the processing right now, but they do it at something like a negative 80% margin or something crazy like that. So you guys would have to be like a lot cheaper for this to make sense. Can you give me a sense of that comparison?
Yeah, so that the negative margin is really only towards lepidolite, and lepidolite is so difficult to process because it's essentially a cyclosilicate, very, very stable. So if you heat it up, you have to heat it up around 60% more than spodumene. So spodumene is the one that's sold most. Spodumene cost is around $1,500-ish to process per ton. We're looking at around 1,100 to 1,200 per ton.
Okay, yeah. Thank you.
All right, Carolina.
Hi there. So we're based in the UK. We're basically a VC fund that invests in science-based startups in the energy and space sectors. And my questions are mostly around IP. Can you just talk a little bit more about what's protected, what isn't, and is there any infringement on the work that you've been doing previously? Yep.
No, great question. Yes. So what I was working on the Department of Energy or Department of Defense for the Department of Energy was an organophosphate hydrolase. So it's a similar hydrolase. However, the one we use is actually a deep sea vent dwelling organism. That's where we extracted it originally from. I also work a little bit with the Discovery Channel, so perks of the job. We found it there. Highly thermostable, highly pressure stable, and pH stable. So it is about 2% sequence homology to one that was used previously, but the exact same mechanism of action, hydrolysis. In terms of patenting, we have 3 patents right now, and those are for the use case, as well as very specific amino acid sequences for those mutated ones. The mutations actually come into play because we kept the active site the same, but we've changed the binding pocket to fit very specific crystal lattice structures. And then the actual process is kept trade secret. So what reagents do we use to precipitate out certain metals versus others? How do we keep the silica gel from doing a polycondensation? Those are all trade secrets. So it's a good mixture of patents and trade secrets, with Wilson Sonsini being our counsel.
Thanks.
Last question, Bill.
Hey, Bill Weber from 3M Ventures. I'm just curious about technical barriers to scaling. Are there, I mean, obviously the vessels and things like that, you can get a 1,000 liter vessel, not a problem. But in terms of producing enough of your active ingredients to get to scale?
Yeah, great question. So in terms of the hardware is actually going to be based on the oil and gas sector's use of water processing. So the same ones that are already used there, we would use the exact same thing. And actually, water processing brings us to the next point. There's a lot of biological anti-fouling and decluttering agents that are already used in municipal wastewater treatment facilities. We would operate around the same quantities and around the same amounts in terms of size and concentration in the brine. So it actually works out pretty well for us. Now, of course, it's just how do we produce it as cheap as possible and as large scale as possible. As of right now, we can grow it up essentially in buckets and totes. It doesn't need high sterility, so that really brings down the cost compared to most recombinant protein production.
Great, thank you.
Thanks. Thank you, guys.
Cool. Yeah, thank you. Thank you for the presentation. That was a lot of fun. Feel free to leave some of your contact info in the chat. It seems like there's some good interest here. Yeah, thanks again. Next up, we have Scott from Dasco. Scott, the floor is yours whenever you're ready.
Hi, I'm Scott Enswinger at Dasco, and our company is historically a distribution and a process company in agricultural inputs and industrial inputs. We've been working towards moving towards more ecologically and economically advantaged materials for a few years now. And the question about that is why do that? And we're pretty simple at Dasco. Is we only have one Earth, so why not make it better? And so that's the kind of thing we focus on. That's our why.
Hey,
So
Scott, you're in presentation. Your screen that's sharing is in presentation mode or the presenter mode. So it's like what you should be seeing pretty much. Like we see a preview for the next slide and everything.
Okay, I'm not even sure how to deal with that. So
You could end share and then try to share again.
Yeah.
Using
that.
The right one.
Dots at the bottom sets the presenter mode.
I don't see it. So
it's on the right side on the bottom. One of
Oh, you mean near the
on your
the
screen.
zoom in and zoom out?
Now there should be another one. Stop if you.
Just click share screen or just start.
Now the three dots that you see on next to the camera icon on the left side.
I don't see it. I'm sorry.
Below where it says Dasco,
And
just
then
before.
I could,
Yeah, presenter view, high presenter view. Missed it.
that work?
We're back to PowerPoint full screen.
I'm sorry, guys.
Oh, yeah.
In order to expedite this, I can just talk over and we can go. My slides.
Yeah, that's fine.
What's that, Asher?
That's fine. You can just go ahead.
Yeah. So anyway, our companies, we've been involved in agricultural distribution since 1996. We work today mostly in the development of ecologically and economically advantaged materials to solve problems that our customers have in industrial and agricultural spaces. A big part of that is we've kind of evolved into a platform where we do our own R&D in-house. We work with collaborators to develop R&D that they have available that needs to come to market, and the customer base from our broad experience in both agriculture and in industrial spaces for people that have problems that need to be solved. A big part of what we do today is work with biogenic materials, carbons, and biochar is a important part of our work. We started with biochar about 3 years ago, just because it has so many interesting characteristics, and we believed it could be engineered into materials of significance for the world, essentially. And since that time, we've done a lot of work to characterize that material, and we do a lot of work to engineer it to make industrially viable materials. A lot of our work is in water remediation. Today, we are focused primarily on the removal of metals with engineered biochar, engineered carbon. And we have started that work in conjunction with the semiconductor industry as a request to clean up some of the material, the metal, the water that they use in process and to help them recycle water for their ultra pure needs on production as well. All of this has led us to what we're going to talk about mostly today is a number of our industrial partners came to us and asked us to help them develop a methodology to deal with railroad ties that are in the environment. And so we developed a method to pyrolyze the railroad ties, essentially. It's a highly exothermic reaction. We thermally oxidize the synthetic gas that comes off of it. We use that energy from the syngas to drive a secondary process where we calcine a marine aragonite material that we get out of the Bahamas. We can make lime with that. We capture CO2. The aragonite is essentially a carbon negative material. It is a very carbon negative material to begin with. So out of this process, this pyrolysis process to make biochar, we today are able to get a carbon material that is we can engineer to solve problems in remediation, agricultural, industrial applications, steel, for example, things of that nature. We capture the energy. We make lime that is very, very low cost relative to the alternative calcium oxide and is very low carbon footprint. We capture the CO2 that is removed from the environment. That becomes another industrial or another economic value chain that we were able to tap into.
Scott, your slides aren't moving if you wanted to switch slides.
You guys can see it. I'm sorry, I didn't realize you could see it.
Yeah, we can see it.
All right.
Yeah, perfect.
There you go. Anyway, so this schematic gives you a little bit of an overview of the process where we use the pyrolysis methodology to drive a number of other systems and create a number of other products. The product lines that we come out of it, the verticals that we can come out of it with are industrial carbons. We are beginning to work with the manufacture of turbostratic graphene out of this process. Carbon dioxide, the lime, electricity is generated at the very end of the process through ORC systems and carbon credits. So there are a number of economically viable verticals that we can produce, and we have partners that are interested in all of these, and we can sell to a variety of different applications. And so I'm trying to go as quick as I can. What is Desco looking for and what do we do? We mostly are looking for collaboration with industrial partners who have problems that need to be solved that we can address with the pyrolysis process by upcycling waste materials. Pyrolysis is and thermal oxidation is an effective way to remove PFAS, for example, from waste streams and other organic compounds that can be used to condense valuable materials, chemistries from the synthetic gas that comes off of these processes. The biochars and the carbons that are manufactured are industrially useful and valuable. Additional things that we're looking for are collaborations with creators to bring into our platform and help them be able to develop products that are both useful for the general public and also materials that are useful for Dasco. Companies that offer synergies with us are engineering, manufacturing, testing. They oftentimes are synergistically valuable in our process to be able to link them with collaborators in our network as well as our own projects. Dasco offers consultation relative to the pyrolysis and biochar space and carbon space, and that looks like that will lead into the graphene space as that industry we believe is about to expand rapidly. And we also have our own in-house laboratories where we do product vetting and do collaborative R&D on promising materials that we think can be used in both our own businesses and those of our customers. So sorry about the slideshow disaster, but our executive team we have a broad base of experience in distribution, chemistry, biology, and other aspects of business in general. Our principal investigator is Dr. Eric Bendala on staff that runs our R&D. And if there are any questions, I'd be glad to answer them.
Perfect. Bill, go right ahead.
Yeah, hey Scott, thanks for the presentation. This is Bill Weber from 3M Ventures. What is the market you see for turbostratic graphene?
It's we think it's extraordinary. Turbostratic graphene is a few more layers than the graphene we often think of as single layer or few layer graphene. It's not as organized as those, meaning the sheets of graphene are offset. We see that material going into many types of composites, building materials, electronics, obviously, and we believe that it has a space in water treatment as well. So we're working with it a little bit in the laboratory right now. We've just started on that relative to water treatment, and that will lead on into materials and other applications.
Yeah, that's interesting, and I agree with all that except maybe the electronics. The one area I would encourage you to look is concrete and asphalt, particularly if it's low cost, because there are papers out there on the impact of very minor additions, like 1% and less, and how it can extend the lifetime of both concrete and asphalt. So just a comment there. Thank you.
Appreciate that. Yeah, and you're right. We're seeing efficacies at 0.05% inclusion in concretes. We think that has value there. We also think that by adding that additional strength with concrete with the graphene, that opens the concrete up to being able to take on more raw industrial carbon or biochar, further reducing that footprint. And with our low to zero footprint calcium oxide coming out of that process, it's a promising opportunity for concrete, no question.
Perfect. We have time for one more
I have a
question.
question. Can you
Sure.
say a
Robert, go right ahead.
little bit more about the semiconductor applications that you mentioned at the beginning?
So semiconductors came to us as a request from some industry folks to help them clean up their processed water. In the processed water, after manufacture of semiconductors, there tends to be a lot of metals in there that are difficult to deal with and also have value to be reclaimed. And so with one of our high temperature carbons that we're manufacturing out of the railroad tie pyrolysis, we've been able to demonstrate 5 to as many as 10 times increased efficacy at metals absorption with that material versus activated carbons and other absorptive models. And we believe we're working right now in the lab to be able to reclaim those metals back out of that material after it's absorbed. And we think that not only is it possible on the back end of that material, but we may be using this material in the front end to help in the ultra pure water processing aspect.
Thank you.
Perfect. Paul, did you want to do one last quick question? Okay.
All right, then. Thank you very much.
No.
Okay, good. Thank you so much, Scott. Feel free to leave your contact information, and thank you for the presentation. With that, we are getting to the final 3. I believe next up we have Blastwave, and from Blastwave it looks like we have Cam. Cam, go right ahead whenever you're ready.
All right, so I hope you can hear and see me. Thanks everyone for the time. My name is Cam Cullen. I'm the CMO of Blastwave, and we're a little different than some of the other sessions today. What our goal is to make sure that we protect the networks that run all of the energy out to consumers, as well as your manufacturing, your fabs. We have customers in oil and gas. We have customers, actually, one of our customers runs a clean energy data center that's basically completely powered by solar, as well as a number of other spaces, including in the Air Force, where we're protecting basically the base-wide systems. And the reason that Blastwave is in existence, it really is because that operational technology networks are under attack. Over 31% of administrators of OT networks reported more than 6 attacks in 2023. And 60% of these attacks, specifically for OT networks, are targeted for disruption rather than financial gain. A lot of that is because of the geopolitical situation that's going on around the world. So they're not necessarily trying to make money as much as cause disruption. And as well as that, we're also seeing a huge uptake in the use of artificial intelligence, things like ChatGPT, for example, to aid in hacking, specifically things like phishing. Huge increase in phishing when ChatGPT was released, makes things a little more professional, and you can use it to make things more targeted based upon the public profiles of people. So the threats are continuing to rise. And at the end of the day, most of these attacks do result in downtime. And right now, the average for energy for downtime is over almost $2.5 million per hour if your network goes down. Someone messes with your devices or basically your distribution, that causes severe both financial loss, but also reputational loss. And in the power space specifically, you can take down hospitals. So there is a big impact when these networks go down. Blastwave is a specialist in the protection area. If you're familiar with anything in the cybersecurity area, we're all about making sure that we don't let people into your network. We have partners that figure out all the rest of them, or what happens, recovering and detecting and doing identification. But our goal is to build that strong front wall to not let people in your network. And we do that because what we're trying to do is first shield your network from from attacks, not letting them discover your network. We want to make sure that your employees who you want to allow in can get in with secure remote access, but only allow them to see exactly what they're supposed to see and not basically be able to roam around the network. And in energy, this is really important when it comes to having temporary contractors or other people who are going to come into your network for a period of time, but then you don't want them to have access to your entire system. And then we also prevent lateral movement with microsegmentation. All of these are big parts of the NERC CIP requirements, which have been levied upon energy by the governments, specifically in the US, obviously with NERC CIP, but around the world. This is a big requirement. And what we're trying to do is we take these requirements, and we have some very specific, unique technologies that we've developed that we call network cloaking, our phishing-resistant secure remote access, and software-defined microsegmentation, where you can implement these changes and security in your network without re-architecting it, without re-cabling everything, without doing a whole bunch of work, or changing the way that your employees do work, which is a big deal in the OT space, because people like to do work the way they want to do that, not be forced to change their ways because of security getting in the way. And our solution is much cheaper than anyone else. We're all software. It's a SaaS model. So we don't sell hardware. It's all a subscription service. And it's a much simpler to maintain, and is a lot higher performing than our competitors. And we do eliminate entire classes of risks. So I won't go into the whole MITRE attack matrix, but essentially there are a number of different mechanisms that hackers use to get into your network. And of the 90 components that have a network aspect, we block 84 of those 90 attacks, including the most common ones. So we are a solution specifically designed to drastically lower the risk of putting your network out there and running your networks automated. And we do this, as I said, far cheaper than other vendor solutions from the larger vendors, as well as some of the newer vendors that are competing that leverage some more high cost ways of deployment, like through the cloud, which for many private networks is not an acceptable way to deploy security by leveraging, a public infrastructure. We even have a great example that happened very recently where we had a new customer that deployed us. Their systems got hacked, and the only part of their entire network that remained operational after this attack was the portion deployed with Blastwave, and they're now placing orders with us to protect the rest of their network, because we proved essentially that when their other systems weren't working, ours still were, and we saved them quite a bit of money by keeping one of their factories running when the rest of them were shut down. So this is really worth it. We are in the process right now of raising a $13 million round. We are deployed. We have revenue. Obviously, if anyone's interested, we'd be happy to go through what it is. But we are a proven solution and have our systems deployed today in places where they are protecting these networks and keeping them running for both energy, for manufacturing, for water, for basically all aspects of the critical infrastructure side of the house. So that's quick. And I know we're a little different than everyone else that presented, so I want to just give this to you. And if you have any questions, I'd be happy to answer them for you.
Sure. While people are getting their thoughts together, feel free to butt in if you guys have questions while you're getting your thoughts together. But I wanted to hear more about, some of the more of the use cases you guys have, especially on the government side, but also on the energy side. I know that, I think resiliency is one of the keywords I've heard over and over and over again recently. Can you talk more to that a little bit?
Sure. I mean, one of the things that we see, especially in the energy space, is that so many things are very remote. So you have to have that remote access to them. You don't want to have to send someone out as a technician to get access to pipelines or sensors or whatever. So by making sure that those systems can be controlled via the network, but yet let your employees enter that securely and not let hackers discover and find them, that's a big deal. One of the challenges in the energy space specifically is that the technology that's deployed out in the field often is old. It can't be patched. The systems or sensors are ones that are 10 years old that are not going to be updated. So we make sure that we hide and protect those systems from the network, so a hacker can't discover that you have a particular brand of sensor out there or humidifier, whatever the sensor is, and not let them exploit well-known vulnerabilities in those to take down or to move throughout your network.
Sure. That makes perfect sense. That makes perfect sense. Well, we do have time for one more question, but it seems like some people are shy, but that's okay.
I've got my email here, that's Cam@Blosswave. If anyone has any questions to follow up, just feel free to reach out.
Thank you so much, Cam. I appreciate the presentation. All right, next up, we got Odin AI. We're ready whenever you are. I can't hear you, David, or at least I can't on my end.
Oh, I was muted I was muted physically.
There you go.
There, you hear me now?
Yep.
Excellent. Okay. 1 second here. Okay, so you guys can see that slide, right? It's not showing
Not
me.
yet.
Okay, okay, so it says it's sharing. You're not seeing that?
Sometimes it takes half a second for it to load.
Okay. I'm going to share this instead. Let's see if that works.
Oh, there it is.
Okay. It wasn't liking sharing the physical screen. It wanted me to share the actual PowerPoint app. Anyway, hi, I'm Dave Cook. I'm the founder and CEO of Odin AI. We build artificial intelligence for signal analysis and prediction. My background is oil and gas, and that's our primary industry that we've targeted. Our software is sector agnostic, but that's where we're focused. So what the problem that we're solving is the oil and gas companies, essentially, while we've brought down the cost of oil and gas substantially with fracking over the last 20 years, it's still antiquated. The data it's not really organized. There's never time for look back analysis. And companies, even though they're collecting terabytes of data, it really outstrips their ability to use it in any sort of meaningful way. Any analysis is typically look back after the fact. Well, maybe we could have done this better. What artificial intelligence allows us to do is flip that, where we take that data, we can actually start forecasting forward to optimize operations in real time. And there's 3 areas where we see that manifesting. One is in risk mitigation, so problems when a well has a failure. And there's lots of different failure mechanisms. I won't go into too much detail about that. So that's sort of like, that's phase A of where we see optimization. Phase B is in the production optimization, and there's been some studies showing that if we can, so when we pump these fracks in the ground, I've got some graphics that'll show it later, but if we can get the efficiency closer to unity, or all the fracs the same downhole, that we can increase our production by 30%. So if you look at the United States producing 20 million barrels a day, that would increase to 26 million barrels a day on the same number of wells being drilled currently. And that's like $150 billion a year of additional oil and gas revenue for no additional cost to the USA. And then there's another area where the completion systems that we use haven't changed in 20 years. We've just got more efficient at them. We've kind of squeezed all of the juice out of them that we can. But there's an application to use AI to really revolutionize how we actually frack these wells. What our software does is we integrate with our client systems. We take their data, we extract, we clean it, standardize it, extract features out of it, build the AI, and then we make those models available for 365 days a year, 24 hours a day, on-demand access. Making making the AI model itself is not complicated. It's actually getting all of the data to the point where you can train the model, in the feature engineering as well as another key component, and then making that model systemized so it can run on these wells. Because how you train the model is how it has to run all the time in real time. We had a meeting with a major in Oklahoma City, and they said they've had numerous companies come and present, and we were the first to actually ever present real neural nets and real AI. They said whenever they dig into a company, it's just if-then statements under the hood. So that was a nice feedback to get from a potential customer. Just a quick graphic. This is the first time I presented in a deep tech showcase like this. So I took our pitch deck and I've thrown in a bunch of kind of materials to help explain the tech. So if there's a discontinuity in format, I apologize, but this is just a quick explanation of basically how our workflow is. The data comes in, we're cleaning it, standardizing it, flattening it, feature engineering it. It goes to the model training, and then we store those models for on-demand use. When a customer needs them, the models are available. Like I talked about before, where we see these three benefits, it's in the risk mitigation, production optimization, and then really making this scalable, because that's where you can have a graduate student come in and come up with a Python script or train a model, spend 8 months doing it, but that's not something you can actually put into production. You have to actually have a full software solution behind it to do it. How we build these models as well. So when we did our pilot in 2020, we were the first in the world to do this, and I've got some slides from that coming up. But we take information from the drilling, from production, from logging, downhole sensors, microseismic, and our software, what it's able to do is bring all these very different, disparate data sets together, flatten them into something and you can actually put into a neural net training methodology, train a model on that to predict your features or whatever it is you're looking for, and then put that out to production. That's one of the key components. So when we say our software sector agnostic, we've done it with some other industries as well, though oil and gas is our primary focus. This cloud down here that you see, those are microseismic clouds. And I was talking about making the fracs uniform. These are actually listening devices we can install in these wells, and we can actually hear, listen to these fracs growing through the earth. And you can see they're not uniform. They're some of them are larger, some are smaller. And that's the kind of stuff that we can optimize with AI. In that, here's a little diagram to help illustrate the situation. So this kind of pink envelope you see down here, that's a frac growing through the earth. Then there's sort of that cloud, that's the sand. So when we pump these fracs, we open up the crack with water, we fill it with sand, and then we use a physical device to actually divide and move the frac. So we sequentially frac down the well. But when we're doing this process, things can happen like the fracs fill up prematurely with sand, leading to an expensive clean out. Sometimes these fracs can grow into ancient saline aquifers. Those aquifers can flood the well and you lose your production completely. So you lose a $10 million well. But also there's a situation where sometimes these fracs don't cover your entire pay zone, so you're missing out on production. So there's a lot of different angles that we have the ability to approach and extract additional value of customers' wells using this technology.
30-second warning.
Sorry, what's that, Asher?
30-second warning.
Okay, 30-second warning. All right, I'll skip this then. That was just a video of it in action. In our pilot well, we saved a client $500,000 predicting some of these events before they occur. The market for this is absolutely huge. Just on the risk mitigation, that's about $4 billion a year. On the well optimization, I mentioned that's $140 billion, $150 billion of additional oil and gas production per year. We think the serviceable out of that is probably $10+ billion a year. In terms of IP, we have some of the most patents in the industry. Halliburton, you've probably heard of them. Saudi Aramco, biggest company in the world. They've got 21 patents. We've got 6. The source water, they show up in the frac artificial intelligence search, but they're not in the area of what we're doing. So I think we're doing okay on the IP side. And our team, myself, founder David Anderson, he's the #1 guy in North America. If you want to know how much oil your well is going to produce, you call him. John Thompson, great connections across industry. Brad Cook, advisor, CFA. Questions I'd be happy to take.
Perfect. Thank you so much, David. All right, the floor is open. Feel free to unmute and ask whenever you're ready. In that case, I can ask it here. David, can you highlight again some more? I won't trick Pony, but happy to continue doing this. Some more other use cases. I know you spoke about a few. Or there you go, Paul. Go ahead. You saved me.
I'll jump in. Paul Garcia from the Air Force Office of Energy Assurance. I know that you're talking in this case about oil and gas. Have you done any analysis for geothermal fracking, since that's one of the open system techniques? Stimulated.
We haven't. It's on our radar though, because the same methods that we're using in oil and gas fracking are directly applicable to geothermal, and geothermal has some of these new wells where they're multi-stage fracking for geothermal are producing energy that's just like off the charts, and but still they need to gain efficiencies, and we have the ability to help that industry as well.
It's definitely something the Air Force is pursuing for installation energy, because we would do geothermal energy at every single base if we could, and that means we're going to have multiple techniques for geothermal, because not every resource is the same. So whether it's AGS or EGS or pumped hydro, they all have those components, and understanding the subsurface and optimizing that is going to be really an important component of reducing the cost.
Yeah. And one of the things from what I understand so far about the geothermal as well, is that with multi-stage fracking, they don't need as hot rock as historically. And so that opens up a much larger geographic area that you can put these geothermal wells.
Correct. Yeah.
Happy to look at that. If you happen to have intros in that industry, would love to speak.
We know everyone.
Okay, great. Well, let's connect.
We have 3 pilots going on right now with geothermal energy, and we'll be announcing a 4th one in a week or 2.
Fantastic. That's great news. Geothermal, it's like face melting energy. It's unbelievable what I think the future there's going to be.
All right, perfect. Well, looks like that's it. That's a good one. So thank you so much, David. I mean, obviously leave your contact info if anyone, wants to, further ask questions. And we have one more presentation for today, Luftcar. Feel free to start sharing when you're ready, and we'll get going. Perfect, Sam. We're seeing presenter mode, Sam.
Okay, all right. So am I in the presenter mode now?
Yeah.
Okay, great. So wonderful. I'll keep talking. So Luftcar is both a hydrogen vehicle startup and also a hydrogen infrastructure startup. And why we are doing what we are doing? is, we realized that today's eVTOL drone cargo solution does not really carry to last mile delivery in a meaningful manner. So the dollar per 100 pounds per mile is very expensive. That's one of the reasons why cargo drone delivery at large scale has not taken up commercially. And cargo drone delivery for companies like Amazon is very expensive. We
Hey,
also,
Sam,
yes.
So sorry. So we're seeing presenter mode, which means that we're seeing basically the view that you would have, like with your notes,
Oh,
rather
okay.
than like presentation mode.
Oh, okay. All right. Let me do this here. How about this now?
Okay.
Better?
Yes. Yes. That's much better.
Okay, great. So, and also in terms of regional transportation, the dollar per car seat mile is very expensive for current eVTOL companies. That's why economically they are not viable. And from a defense perspective, I've been coming out of defense workshops with Special Operations Command, and now I'm in a tied defense of the Department of Undersecretary invited event today and tomorrow, where we are realizing that we need true last mile logistical connector solutions that could operate on alternative fuels and make these fuels independent or keep us energy independent. And so we are coming up with a vehicle design that operates on alternative fuels at the same time that can be an effective logistical connector. Luftcar's airframe design is very unique. It's patented, and it's more of air cargo drone that could carry heavy payloads over long distances by lifting cargo vehicles, cargo containers, including road vehicles. So we have a unique way of docking the road vehicles. But for this purpose of today's pitch, I'm focusing more on the hydrogen fuel cell propulsion that we are building. We are a systems integrator. We are partnering with companies like Bosch Aviation, ZeroAvia in terms of supply chain, and EH Group in buying their fuel cell stack, balance of plant, and hydrogen storage tank from other suppliers, and we are integrating them into the airframe. So we are the experts of integrating hydrogen fuel cell propulsions into road cars. We have done that in the past, and now we are doing that in the airframes. So we have sized up the fuel cell. We have sized up the amount of hydrogen that needs to be carried on board, and now we are at the TRL 5 level when it comes to the hydrogen fuel cell propulsion technology. And we also are making ground equipment to refuel hydrogen. So we are making modules from all the way from 25 kilograms, 20 kilograms modules to 250, 500 kilograms modules. So we can add them up to provide facilities that are around 2 tons per day. So a 2 tons per day would support a fairly large airport for ground transportation, air transportation. At 250 kilograms per day will support a small naval base and support a few missions for a drone carrier. Our team has got hydrogen experience. We have built hydrogen cars in the past. We're coming from organizations like Ford, GE, Boeing, and US Air Force and Honeywell. We also have a strong advisory team across. We have several interests across the world in bringing our technology to market. Italy, Brazil, UAE, or some other countries that want to build our vehicle. But because the patent is a US patent, we really want to make it happen for the US DoD before we go elsewhere. We have won several awards down the years. We have been selected on the top 10 aviation startups in 2024. We have enormous interest across the globe, like I mentioned, and it's growing day by day. Off late, we have seen more defense. I'll jump to this. We have seen more defense traction. We have been invited to submit a white paper by Office of Naval Research, and we are part of the 757 Accelerator out of Virginia. We have been invited to a Special Operations Command workshop on the Indo-Pacific strategies for logistics connectors. And right now, I am in the Defense Department of Undersecretary of Defense workshop. So we have raised 1.5 million so far. We are raising 10 million for seed. We are looking for lead investors. We already have follow-on investors interested in investing in us. Overseas wise, we are having Italian Army and Brazil interested in developing our vehicles. We are a very unique and elegant solution in carrying drones compared to Elroy or Airbus, and we believe that we have a very viable way of carrying heavy payloads in a very safe manner. Our first markets would be cargo, then it would be defense and regional transportation. We are working with FAA. We are reviewing with FAA our design concept, and our commitment is to give our first two-seater vehicle to FAA for certification. And we are also helping FAA in developing hydrogen-related regulations for eVTOL. So we are forecasting a very large revenue potential, $30 billion in 10 years because of the multiple industry verticals that we participate in. Our roadmap is that we are right now working on a 6-foot demo, and we'll have a two-seater vehicle in a year from now, which would give to FAA for certification, and that vehicle will have hydrogen fuel cell propulsion. But we will be commercial in another 3 years, along with the FAA certification. So that's about it. I'll stop here and open for questions.
Thank you so much, Sam. All right, opening the floor. Robert, are you asking something? No. All right, we have time for questions. All right, Carolina, go right ahead.
I'll save you. Yeah, can you tell us a little bit more about the competition, especially the large players like Airbus? How are you plan to be cheaper, faster, better than them?
Okay, sure. So Airbus has got well, they have a conventional eVTOL, if you kind of look conventional, but they also have a docking mechanism where they're lifting the vehicle from the top. So I'll use my my little cosmetic powder here. So they're lifting it like this from the top, whereas I'm lifting it like this, like how a pitcher holds a baseball, like our eagle carries a prey. So that's the disruption. So ours does not require multiple platforms. In case of Airbus or Elroy, you require other skateboard kind of designs to come and carry this passenger compartment or the cargo compartment away. So we become a 2-piece solution as against a 3-piece solution or a 4-piece solution that Airbus or Elroy does. And also Airbus is working on hydrogen propulsion, but they are more on burning hydrogen. But we are about hydrogen fuel cell electric. So we are zero emissions. We are all about this decarbonization. We'll be using green hydrogen to a large extent. Whereas Airbus is burning hydrogen, so lots of NOx emissions come out of it. Does that answer your question?
Yes, it does. What about the exit? So are you planning to sell, let's say if Airbus would like to acquire a product, would you go for that, or are you planning to IPO?
Well, right now our dominant strategy is to IPO, but you know, I'm open to being purchased by Airbus or Lockheed Martin from a defense perspective. So I'm open to those options as well.
Awesome. Thank you. I think if there's anyone else who has a question, feel free to jump in and ask. But if not, thank you so much for the presentation, Sam. Feel free to leave some of your contact information in the chat. With that, I believe we have run the circuit, and you know, everyone who was supposed to present has presented. So I'd like to give a thank you to everyone who's presented, like yourself, Sam, and all the panelists who have joined us today. Thank you for making this event. Really appreciate the attendance as well as the presentations. So thank you to everyone, and stay tuned for next month's showcase around autonomous systems, which should be a lot of fun. Thank you, everyone, and have a good rest of your day.
Thank you.
Thanks. Bye.